Assalamu alaikum wa rahmatullah. Good day, everyone, and I welcome you all to our exciting physics class. Today, we will solve the second problem on electric current. This problem reads: calculate the drift velocity of the free electrons in a copper wire of cross-sectional area 1.0 square millimeters when the current flowing through the wire is 2.0 amperes. Number of free electrons in copper is 1 times 10 raised to the power 29 per cubic meters. Okay. Um. The first thing we are going to do is to identify our target variable. What is it we are trying to calculate? And that is the drift velocity and is given the symbol V. Okay, next we are going to identify the parameters we are given. They said calculate the drift velocity of free electrons in a copper wire of cross-sectional area. Okay, this is our cross-sectional area and is given the letter capital A. But this is not in the SI unit. To change it to the SI unit, we have to multiply it by 10 to the power of -6. Now it is in square meters. So when using this value, we will always multiply it by this. When the current flowing through the wire is this, so this is the current I have written it already. This is the current I. The current is denoted by capital I. Number of free electrons in copper is this, meaning from here we can see that from the unit, this number is our small n that we call charge carrier density. The number of free electrons in every 1 cubic meter volume of the material. Okay, the next is to ask ourselves what is the formula that combines all these parameters together so that we can make V the subject of the formula and calculate it eventually. That formula, let's begin by writing solution. That formula is I equals NAVE. The electric current is equal to charge carrier density, what we are given here. Cross-sectional area is given here. V, the drift velocity, is our target variable. We don't know it. E is the electronic charge, and we know it's a constant, even though it's not given in the problem. We will always use 1.60 times 10 raised to the power of -29, -19 Coulomb. Okay, we know our current. Our current is given here. This is our target variable. We don't know it. So we have to make it the subject formula. To do that, we say V is equal to, we take this I and divide it by everything here except V. So we divide, we bring N here, we bring A here, we skip V and bring E. See? Next is substitution. Substitution. What is our I? Our I is 2.0, so we write 2.0. Next, we open bracket here and say our n is this, so we write 1 times 10 raised to the power of 29, then times A. Our A is this 1.0. 1.0 times 10 raised to the power of -6, then times E. Electronic charge is not given in the problem, but is always 1.60 times 10 raised to the power of -19 in Coulomb. Then we close the bracket. Okay, next, let's bring our calculator. Now, what we are going to do here, we have the numerator 2.0, so we press that, we press 2.0. See, we have the 2.0, then press divided by, because you have the dividing line, and now you open the bracket. Open the bracket, so you open bracket, this is necessary. Open bracket, press one exponential. Can you see this is the exponential? When you press exponential, you will see times 10. Then now write the power of 10, 29. Then times again 1.0 exponential 6, negative 6. So for the negative, you press this one, this function, and the negative appears. Then you press 6. Then times 1.60, 1.60, again exponential, then you press negative again, 19. Finally, you have to close the bracket. You see, after closing the bracket, press this equality function, and you have 1.25 times 10 raised to the power of, you have something like this, meaning 1.25 times 10 raised to the power of negative 4. So our result is 1.25 times 10 raised to the power of negative 4 in meters per second, because this is the drift velocity. Now, finally, you have to ask yourself whether this result makes sense or not. And of course, it makes sense. Why? Because in our previous videos, we explained that this drift velocity is a small value. It's not a large value, okay? So if instead you obtain 1.25 times 10 raised to the power of positive 4 without this negative, okay, it means you have about 12.5 thousand meters per second. This is inconceivable. This is impossible. Meaning, if you calculate your V and you found out a very large value, you have to go back and check the process. Maybe something is wrong. Probably you did not use the right formula, or you didn't make correct substitution, or these conversions, you didn't make the conversions. If one or two things are missing, you will not get your V accurately. Okay, and my point is, one way of checking whether your V is right or wrong is to look at the value. Is it small or large? If you have a large value, significantly large value, it cannot be V, because V, drift velocity for the free electrons, is always small. And what we got here is a small value, so that makes it correct. This is all we have for today. Thank you for watching.